In 2012, a memo titled Project 1794 Final Development Summary Report, 2nd April to 30th May 1956, was finally declassified by the United States Air Force, describing an aircraft with the capability of flying, quote, between Mach 3 and Mach 4, a ceiling of over 100,000 feet, and a maximum range with allowances of about 1,000 nautical miles. Schematics for the report revealed an intimidating and revolutionary form. Jointly developed with the Avro Canada Aircraft Manufacturing Company, Project 1794 was to be America's secret flying saucer. Its mission would be to hunt down and intercept Soviet long-range bombers. Its otherworldly shape would have the added effect of bringing psychological war to the enemy. Jack Frost. Known as Jack Frost, John Carver Meadows Frost was a British aircraft designer and the mastermind behind the Avro flying saucer. He worked on experimental supersonic aircraft for the United Kingdom and on Canada's first fighter jet project, the CF-100. While working on the CF-100 research team, he created a special projects group, a collective of experimental designers and engineers housed across from Avro Canada's headquarters who worked on secret creative projects. Project Y. During Frost's work, the aircraft industry was starting to look into vertical takeoff and landing technologies. Conventional knowledge pointed to the future threat of a nuclear war, which would inevitably result in the destruction of air bases. This meant that aircraft would need to take off and land on limited space or unprepared fields. Avro Canada's Project Y was the result of considering such development in combination with supersonic speed advancements in the 1950s. Notably, Project Y introduced the possibility of creating a circular aircraft resembling a flying saucer. The conceptual design was based around using exhaust from turbojet engines to drive a turbo rotor for thrust, creating a cushion of air and letting the aircraft fly at low altitudes. Directing thrust to the rear would make the plane accelerate while gaining altitude. Frost almost saw his project die when the Canadian government pulled out the funding that had been set up in 1952 due to high costs. Towards the end of 1953, American defense representatives visited Avro Canada to see their new CF-100 fighter jet. Knowing the United States poured far more resources into new technology, Frost took over the tour and made sure to stop at his special projects building. There, he showed them the mock-up and design documents for Project Y, some of which his superiors hadn't even seen. They were impressed, and the U.S. Air Force gave him a $750,000 contract that was supported by Avro management in 1956, with an additional $2.5 million for a prototype. In March of 1957, the U.S. increased its funding, and they were able to build a prototype. Avrocar. Several vertical takeoff and landing designs were considered by the Special Projects Group. Still, all featured the disc-like shape suggested during the beginning of Project Y. They decided that their result needed to be a huge supersonic disc-shaped fighter. The design had a raised section in the middle on top of the engine. Its intake was covered with horizontal slats to admit air. The concept developed by Frost indicated performance estimates that sounded encouraging to the U.S., with a potential for reaching Mach 3.5 at altitudes of around 100,000 feet or 30,000 meters. Not all members of the U.S. Air Force were supportive of the project. Several branches wanted to secure funding for experimental pet projects, such as nuclear-powered aircraft. At first, the idea was to use a new engine made of 6 Armstrong Siddeley Viper engines on the outer rim of a rotor. This new engine, PV-704, used a stopgap design that was tested with disastrous results, catching fire on 3 occasions. It was so notably unreliable that the staff was afraid of testing it, even when these tests were conducted behind a bulletproof glass and steel booth. The final test of this engine took place in 1956, resulting in the test engine running out of control and exploding, which led Frost to pursue less dangerous alternatives. While the engine concept was being revised, Frost decided to build a proof-of-concept smaller version of the aircraft that he named Avrocar. He pitched the idea of the smaller prototype to the U.S. Air Force. He received a $2 million joint services budget for 2 models. Later on, the Air Force added $700,000 directed from the 606A program and $1.77 million for the development of the second model. He would also build an aerodynamic test bed for the WS-606 final model. The initial requirements expected from the Avrocar proof of concept were that it could hover for 10 minutes in ground effect with a range of 25 miles or 40 kilometers and a payload of 1,000 pounds or 450 kilograms. Frost's projections were incredibly promising. He expected the Avrocar to overperform the metrics expected of it by the U.S. Air Force. Unfortunately for the flying saucer, it would underperform. Testing. As the test models were being assembled, the first grand obstacle struck. The Avro CF-105 Aero program was cancelled by the Canadian government in February of 1959. In response, almost all Avro Canada employees were laid off. The Special Projects Group was left with very few people. A couple of days later, once things stabilized, some of the SPG employees were rehired, but the team had to mix with two other teams and work in the main building. These less ideal work conditions contributed to an overall decline in performance and satisfaction. In the immediacy of the chaos, the U.S. Air Force Project Office decided to cancel the development of the WS-606A, the expected final version of the flying disc. A work order was sent to Frost with the instructions to halt development, and he had to plead for the continuation of his work. With reluctance from several members within the Air Force, funding was resumed. Scale model tests at Wright-Patterson Air Force Base in Ohio revealed that the air cushion meant to lift the Avro car would become unstable once the vehicle passed an altitude of a couple of feet. This indicated that it would be unflyable. Furthermore, it could not reach supersonic speeds. However, testing was still carried out to see if Frost technologies could be used by the Army anyway. Avro car number 58-7055 was the first to come out of the Malton, Mississauga factory in May of 1959. Using a static hover rig, the Special Projects Group tested the vehicle. Several problems were quickly identified. The exhaust was sending hot gas straight into the intakes used to hover, which in turn reduced the engine thrust. Furthermore, and as projected by initial separate technology tests, the fan was generating lift that only covered a small area of the vehicle's surface. The combination of these factors meant that the Avro car could only carry 3,150 pounds, or 1,430 kilograms above ground effect. At the same time, the empty weight of the vehicle was 4,285 pounds, or 1,944 kilograms. Since the Avro car could lift less than it weighed, it was incapable of hovering above ground effect. Following this disappointing performance, it was sent to Moffett Field, California, so that the NASA Ames Research Center could test its abilities in controlled wind tunnel tests. NASA's findings were just as discouraging. The aircraft was difficult to control during high-speed flight and was incredibly unstable. These findings were reaffirmed by flight tests using the second Avro car prototype. Modifications ensued, resulting in a first free flight test on November 12, 1959. There were still several issues that had to be overcome. First, the control system for the nozzle was inefficient. Second, problems with the spoilers made the vehicle difficult to lift so that after reaching a certain height, it would automatically begin to lose altitude. Only 5 initial test flights were conducted, resulting in 18.5 hours of total flight time. On December 5, 1959, testing was temporarily halted. Still convinced that the concept could work, Frost sent in a proposal for a new program that would rework the propulsion and control systems for the second Avro car model. The first model underwent modifications based on the findings of the Ames Research Center, and its testing was resumed in April 1961. The resulting design yielded greater control of its hover capabilities and better lift. Speed was increased to 100 knots or 190 kilometers per hour, instead of the 56 kilometers per hour it had displayed so far. Yet issues with the aircraft's pitch remained, and during flight, the Avro car's nose tilted upwards. After Frost's request to rework the systems on the second Avro car went through, he was able to modify and test it. The aircraft underperformed with a maximum speed of 20 knots, or 37 kilometers per hour. Still, they passed an altitude test showing it could travel over an 18-inch deep ditch while hovering. The second Avro car was still not able to gain much altitude, since surpassing the critical height resulted in significant instability. The report on these tests also pointed out uncontrollable roll and pitch movements, which the Special Projects Group had no way to fix. After all these attempts, the second prototype of the Avro car logged around 75 test flight hours. The project seemed like an absolute failure, since the car could only hover above the ground and not fly. The design limited its speed while making it unbearably hot and noisy, meaning any military use would have to account for lack of basic stealth. Yet Frost still believed in the potential for the aircraft and the lessons learned from testing. He submitted requests for further modifications. Cancellation. Rather than continue with modifications proposed by Frost, the Avro car was cancelled come December of 1961. Executives at Avro Canada still believed in the progress made and sought to secure Canadian or international funding for further vertical takeoff and landing disc aircraft or a lift jet version. Still, they could not find any interest and had to close the Special Projects Group. The 2 models of the Avro car produced belonged to the United States, but the second model was lent to Canada for display. After being outdoors, exposed to the elements, it was sent to the U.S. Army Transportation Museum in Virginia for restoration. The first Avro car was sent to the National Air and Space Museum in Maryland, but was in storage until the National Museum of the United States Air Force in Ohio borrowed it. After being restored, it was put on display and has since been at the Presidential Aircraft Gallery.